Go. Hello everyone, and welcome to today's session, which is a continuation of the session yesterday. Um, these two of you joined, so feel free to interrupt me whenever. Okay. Um okay. So let's start. So yesterday we did linked list. Any doubts on that? What we did yesterday? We did we basically created a list. First, we made a class and created a list using that. We created objects which stored the values that we needed to be in the list. Okay, so we basically the list itself was an object and we added values to it, and then we performed an operation that is multiplication. Okay, your assignment had something called as
Sir,
addition.
your screen is not visible.
Yes. I've not yet shared it. But yeah, so that was yesterday. Any doubts on that? If not, we'll start with today's. We'll continue with what was left.
Sorry, sir. Yesterday I joined late.
Sorry?
Yesterday I joined the class latest.
So no problem. I have uploaded the video. I will upload the video. It's uploading right now. Uh,
Okay, sir.
and I will give you the code also for it. Okay. Today we don't have any coding to do. It's just concept based. So let's start. So you all can see my screen, right? Yeah. So there is this thing in your assignment called lexicographic permutation. What it is basically rearranging letters in a given word in alphabetical order. Okay, like how you see in a dictionary. Okay, lexicography is basically a dictionary. You have to arrange words so that you have to change the letters in a given word in a way such that it's in alphabetical order. Okay, let's do an example. Okay. So first, how to do it is, okay. So you have, suppose you are given a string, say A, B, C, D or whatever. So the first step that you have to do is, okay, given a particular whatever string of letters, for example, let it be A, B, C, D. Then you have to find the first character, okay, first character on the rightmost side, okay. You have to find the first character of the not the first the rightmost character which is smaller than its immediately next character. Okay, for example, I'll show you. We'll do this step by step. Okay. uh yeah, example. Suppose I have given you a word abcd. Abcd. Okay, now what you have to do is you have to, step one, find the rightmost letter in your string which is less than the immediate next letter. For example, here what is it? It is C, right? Because this is the rightmost character, and the next character to that is D, which is greater than C. Okay, so C is your first character. This is it. This is the rightmost character, which is the smallest, such that you have to find the rightmost character such that the letter next to it is larger than it. For example, if there was something like, if I not A B C D but A B C D D C or something like this, then which is a rightmost character which, okay, such that the character next to it is the smallest. Which one is it?
D.
D, right? Because D is lesser than S. Okay. For example, let's do another thing. Not A, B, C, D, D, S, D, S, C. Now tell me which is the rightmost character, which is smaller than the character next to it on the right side. Which is it?
B.
It is D again. Yes, because again D is lesser than S, and S is not lesser than C. So you start looking from this side, okay, and the first character that you hit, such that the character on the right is smaller to it, that is your first character. Now just keep this in mind. This is step one. Okay. Step two is, now you have to identify another character. Okay, step two, which is, suppose we'll start with this ABCD. Okay, let's keep a simple example. Now you have to find the first character on the right of this character that you have found. So on the right of this C, okay, which is, okay, find the ceiling is a small, which is greater than the first character, okay. Ceiling, so it's called the ceiling character. It's basically called ceiling is the smallest character on right of the first character, which is greater than the first character. So there are two conditions. It should be the smallest character on the right of the first character, which is also greater than the first character itself. Okay, did you get this? So let's see. Now, what is the first character? What is the character on the right of C? It's D, right? Now, is D greater than C? Okay. Is it greater than C? It is, right? But you have to have one more condition. For example, if I had E also, A, B, C, D, E. Now, both D and E are greater than C, but you have to choose the smaller of the two. Okay. Basically, the minima of all the characters on the right, which is first greater than this character, but it should be the minimum of those. For example, D and E both are greater than C, but D is lesser than E. It's lesser than, well, if you consider between D and E, D is the least character. So this is your second character. Okay. Now what you have to do is step 3 is swap. Okay. Swap. What you have to do is just interchange your C and D position. So it will become A, B, D, C. Okay. So now this is your word. Forget E now. Okay. Now what is the last step that you have to do? Sort the substring in non-decreasing order. Basically, it should be increasing, or it should not be decreasing. It should be at the most non-decreasing or increasing after the original index of the first character. Okay, after the original index of the first character. Now, what was the index of C in this? This was 0, 1, 2, right? Index of C was 2, right? Yes or no?
Yes, yes, yes.
So 0, 1, 2, that's D here. Now, anything that is occurring after D here, everything that is occurring after D here should be swapped in ascending order. Okay. Now you have just one letter here, so there's no arranging to be done. It's only eating. Okay. Let's do another example. Okay. To be clear. A, B, C, D, E. Okay. Let's see what the next thing is. So what is, maybe not this A, B, just something. We'll make something up. Okay. Now tell me, what is the first character from the rightmost side that is such that the character next to it is lesser than it? Which character is it? You have to look from the right side and come stop at the first character such that the one next to it, so start looking from this side. E, F, C, and when you each character that you encounter, the character next to it should be lesser than that. What is the first character that you
Yep.
see? Can you tell me?
Yes, sir.
No, not F, no, because E is lesser than F. It's not greater. It's C, right? F comes after C. E comes before F, right? So it's C, no? First character from this side such that the character next to it on the right side is lesser. So if I see E, it has no character on the right, so forget it. Now you have F. Now is F lesser than E? No, right? Then you go to C. Is C lesser than F? Yes. So the first character is C. Okay? Is it correct? Can you please tell me? Hello?
Yes, sir.
Did you
Yes, sir.
understand?
Yes, sir.
Okay, now you have to find, so look on the right side of C and find all the characters that are greater than C. Which one are characters greater than C? Both F and D are greater than C, no? Yeah? Now
Yes, sir.
what is the minimum of F and E? Which is the minimum of F and E?
E.
E, right? So it is E. Now you swap these two. Okay, swap. So it is A, B, D, D, E, F, C. Okay, this is your thing. Now after C, so what is the index of C here? It's this, right? So it's basically the what index of E here. E and E, index of C and E are the same thing, right? Yes or no? Same, right? C and E, the index is the same, right? I need to hear a yes or a no, otherwise I can just. Did you understand? Yes, are people there?
Can you repeat it, sir?
So now what is the index of C? So position of C, it's the same as that of E, right? In this new word,
Oh, yes, sir.
yeah. Now leave that position, and then all the letters from starting from that side, going from that position to the end, you need to arrange them in alphabetical order. Okay. So FC will become CF, no? Rearrange. Yeah. So it will become A, B, D, D, E, C, F. Okay. Yeah.
Okay, sir.
Did you get this? So did you get this? So this is basically this word. If you are given this string of letters, the immediate next word that will be formed is this. Okay. You can check it. Okay. Now in your assignment, you are asked to find the letter before it. Now let's try and go from this to this. Okay. Let's try and reverse it. So what do we have to do? Suppose now reversing. Okay. Uh, let's do this. We need to get basically from this word, you need to get back this. Okay. Let's see what you have to do for that. You just have to reverse the steps. Okay. I'll put this here. Insert. Okay. So example for reverse permutation. So basically going one step back. Okay. So it, okay. Suppose given you have A, B, D, 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 E, C, F. Okay. Now you have to get the word immediately before this. Okay. Here we got the word immediately after this, which is this. Okay. Now given this, you need to get back the word immediately before it. Basically, you need to get this back. Okay. So let's do that. What you have to do is step one. Okay. Rightmost, instead of finding the smallest character, instead of finding the character such that the letter next to that is lesser than it, you have to find the word that is greater than it. Okay. So basically, you have to go like this and find the first character such that I'll make this big. Okay. Start from the right side and go to the first character such that the first character that you find should be such that the letter next to it on your right is lesser than it. Okay, so ulta, you have to do the opposite. Okay, so let's see. F, nothing. Now C, is C greater than F? No, right? Is C greater
No,
than F?
sir.
No. Is E greater than C?
Yes, sir.
Yes. So step one is E. So this is ulta, okay? Now step two is find all the letters on the right of E, okay, which is just smaller than E, okay. just smaller. So what are all the letters on the right side of E that are smaller than E? Only C, right? Yeah.
Yes, sir.
So then it is C. Now you swap these two. Okay. You swap. So A B B D C E S. Okay. Now you have to rearrange. Now how do you rearrange? So here we did an ascending order. Here you have to do in descending order from the index of this first character E. So E, what is the index of E in the new word? C, right? Yeah.
Yes, sir.
Now everything after C should be arranged in descending order. So F will come first and then E because F is greater than E. So A, B, B, D, C, F, E. Okay. So have we gotten this back? So is this and this the same? Yeah. It's the same, no?
Yes, sir.
So that's how you have to do it. Here you have to do ulta. So rightmost characters such that the character next to it is smaller than it. That's your first character. Step two is on the right side of that character that you have found, find find all the characters that are smaller than this first character and find the minima, maxima of that, not minima, maxima of that. Okay. Here we found the minima, but here maxima. Suppose if you had E or something else here, C or and even B, then C and B both are smaller than E. But you have to take C, okay? Because that's the immediate maxima, okay? And then swap. After swapping from that index, arrange in descending order, okay? So it was EF initially. After swapping, now it becomes FE, okay? So this is how you do lexicography to find all permutations either in forward direction or reverse direction that are in dictionary order, lexicography order. Any doubts? Okay. If there are no doubts, we will go to the next part. So you had done something called binary search trees. So what is a binary tree? Can someone tell me? What are the properties? Okay, binary search trees has the following properties. Every root has two leaves at least, not more than two. Okay, it has minimum one or maximum two leaves. Okay, every root, every leaf. Okay, or nothing below, but not more than two. Okay, branches. Also, there are no repeating elements in a binary search tree. 8, for example, the value 8 will not, you will not see that value anywhere else. So they are like a set. There are no repeating values. Okay, and the value on the left node, okay, of a left leaf, the value on the left leaf is smaller than its root, and the value on the right leaf is greater than its root. Okay, so 3 is lesser than 8, 10 is greater than 8. Here also 1 is lesser than 3, 6 is greater than 3. Okay, so these are binary search trees. Now let's do an example. You had something called as in-order traversal. Okay, so what is an in-order traversal? This is a representation. Suppose you are given a binary tree like this. You have to follow this
Left
first.
leaf is lesser than.
Sorry?
Can you repeat that point? Left leaf is lesser than the root node.
Yeah. Yeah. So left is lesser than the root and the right is greater than its root. So 1 is lesser than 3, 6 is greater than 3. Anywhere that you see, always the left leaves are smaller than the root and the right leaves are greater than the root. Okay? In a binary search tree. Okay? So let's do an in-order traversal. So there are different traversals. These are basically ways of moving through a tree. Okay, and these are very logical ways. The first one is in-order traversal. So this is basically going first. So for any given structure, you have to go to the left node, root, and then the right node. Okay, right. Sorry, right. Okay, left root and then right leaf. Left leaf, root, and then the right leaf. Let's start, and you have to start every time from the leaves. Okay, in an in-order traversal, always from the leaves. That is basically the bottommost part. Okay, and the left side. Okay, leftmost node. So this is how it is. Suppose you are given a tree. The first step is what is the leftmost leaf here? It's 4, right? Okay. So, so you start from this left, then the root, then the right. Okay, so this is one order. So what is it? You go to 4, then you go to 2, and then 3. No, 3, no, 5. Okay, so it's 4, 2, 5. You have finished this now. So 4, 2, 5. Now this has a root here. Okay, so again, this is left, and this entire thing is right. No, so first left. You have finished this. Now 4, 2, 5. Now you go to the root 1. Okay, then you come to the right. Right is 3 first, and then 3 does not have any left node at all. Okay, so you don't uh, go somewhere here, and then you directly go to 6. Okay, did you get this? So you have to perform this thing
Yes.
recursively. Every node that you see, everything that you see, it will imagine it has both left and right leaf. Here there is nothing, so you just write 4. Then you go higher up. That is its root. Okay, 4, 2, and then you come back here, and then you see whether it has anything. Okay, it has no leaves here. Okay, so you just have to write the node here. So like this, left, root, right. Then this entire thing is left, root, then right. You come here. 3 does not have anything, right? It has no leaf. It has one leaf. The other leaf is not there. Okay, so you just have to write 3, and then left there is nothing. There's only 6 on the right. So basically, you write this
How
entire
did
thing.
one place on the top, sir?
Sorry.
How did the one place on the top?
How is 1 on the top?
Sir, 4 to 5 is okay, sir. Next to that one you placed on the top. How did you place it?
Yeah, so this entire left leaf is this. So then now what is the root of this entire thing? So initially I started with 4, right? 4, 2, and 5. Okay, this entire thing is over now. Okay, this entire tree is traversed. Now you have to go to the root of this entire thing. Okay, suppose this entire thing was a leaf. You have to assume this entire thing to be a leaf. What is its node? 1. Okay, what is its root? Sorry, its root is 1. So I write 1 here. Now you come to the right side. Now this entire thing is a leaf now. You come to its first root, 3. Okay. Now 3 may, do you have any this thing? What you call left leaf? No. So you write 3 here. Okay. Then you have you don't have
Okay.
anything here, so you write 6 because it's its right leaf. There's no left node, no, of for 3. Otherwise, if left had a 3, then you would have written 4 to 5, come here, then you would have written 5, then 3. Suppose 5 was here, there was another leaf here, 5, not 5, say it was 1, because 1 has to be lesser than 3. So 1 cannot be there, not even 2. Actually, there cannot be any more leaves here because everything 2, say it was minus 1. Okay, so minus 1 we can write. So it will become 4, 2, 5, 1. If this had a leaf here, if 3 had a left leaf here, it will be minus 1, 3, and then 6. Okay, it's left, root, and then right. Did you understand? Since there is no left here, so 3, then
Yes, sir.
there's no left at all, so directly from the root itself you go to right, which is 6. Okay, so this is in order traversal. This is one way of moving through a tree. The next one is pre-order traversal. Okay, so pre-order traversal is first, so you have to start from the root, okay? Every time from the top, root. And then it goes root, left, and then right, okay? Root, left, and then right. Okay, let's see how this works. Suppose this was a tree, same tree, okay? Root is what? 1. What is its left leaf? 2, okay? Now you come to this, you have to apply recursively again. Root, left, right, okay? So root, and then left. Now here you have come. Now root, left, right. So again root, left, right. So 1, 2, 4, and 5. You have finished this entire thing now. Now you have to go to the right side now. Right, again come here. There's a root, there's no left at all, there's only right. Okay, so again left is not there, right. So basically the order will be 1, root, then next left, that is 2, then root left right, 4, 2 and 6. Okay, then on the right side you have the right side, that is 3. Now you come here, root left right, there is no left leaf only, then you go to 6. So it is basically 1 2 4 5 3 6. Okay, so that's how it is. We'll do an example. Okay, example for say, yeah, you have to do it in your book. Do you have pen and paper with you? So I'll just make a tree and I'll show you what is
Yes, sir.
uh, suppose your assignment, there was an assignment question. So have you submitted week 7 assignment? I think it was due today, no? Yeah.
Yes, sir.
Okay, so if you have submitted, we can just do it or do the same example. Okay. So you are given this these list of numbers 35, 23, 26, 46, 40, 39, 41, 52. And what were you asked to do? You are asked to do in order traversal, no?
Yes, sir.
In order or pre-order? Pre-order, no, pre-order traversal. You have to do pre-order traversal, right? Yeah. Can you please check and tell me? In order or pre-order?
Pre-orders.
Okay, so let's do pre-order. So I'm assuming everyone has pen and paper with them. So you have to write this in pre-order. Now the root is given, it's 35. Okay, so that's the root. You have to go from the top. Okay, this is how you construct the pre-order tree. You can root left, right, root left, right. Okay. Now what? The next number is 23. Is 23 lesser than or greater than 35? Tell me.
Greater than.
23. Is 23 lesser than 35 or greater than? So everyone
Lesser
have
than.
this
Lesser
list.
than.
Write down this list: 35, 23, 26, 46, 40, 39, 41, 52. Okay.
Yes,
Did
sir.
everyone write it down? Okay. 35,
Yes,
23,
sir.
26, 46, 40, 39, 41, 52. Okay. Okay. Now root left, right. So 35 first is root. Now left, right. Now is 23 lesser than 35 or greater than 35?
Lesser than.
So 23 will become the left leaf, sorry. Then you have to go right. So it's 26 on the right, okay? So 35 basically has two leaves. Left leaf is 23 and right leaf is 26. Okay? Yeah. Sorry, not this, not this. One second. It's not like this. No. You have written 23. Okay. Now the next number is 26. Root left, right. Okay. You have to do the same thing again. Okay. 26 now. Okay. Has two leaves.
So now we have to consider 26 as a root.
Yeah. So 26 as the root. Now 26 is actually, so I've changed it. Let's start again. So 35 left leaf is 23. Okay. Now that is the root.
Yes, sir.
Okay. Now that has 20. The next number is 26. Okay. Now you have to do root left, right. Now does 23 have a left leaf? No, right? Because the next number is not 26. It is something else. It's not lesser than 23. It's 26, right? Yeah. So 23 will not have a left leaf. It will only have a right leaf, that is 26. Is that correct? Yeah. Yes or no?
Sir, can you solve and prove, sir?
Okay, maybe I'll do this on. I'll try doing it on the slide. Okay. So example, pre-order traversal. Okay, what were all the numbers? 35, 23, 26, 46, 40, 39, 41. Okay, now let's start. Now, yeah, let me do. Okay, so okay, let's do it here. I'll make this smaller. Okay, now 35 is the root left right you have to do. Okay, now the next number is 23. Since it is lesser than whatever 35, it will come on the left side. Okay, I will not draw arrows. Okay, so 23. Okay, now the next number is 26. So root left right. Now 23 is the root. Does it have a left leaf? No, because 26 is not lesser than 23. But it has a right leaf because 26 is greater than 23. Okay, so it will have a right insert. 26. Okay, so I'll just draw some line maybe. Okay, is this clear?
Sir, how did
Here?
26 come here, sir? We should place
Huh?
root left and right only, no, sir.
Yeah, root
How
left
did
and
26
right.
come
So
here?
root is 35. Okay, now then you come down. Okay, left 23. Now this is the root now. You have to consider now, do a root operation here. Now root left and right. Left is absent because 26 is not lesser than 23, but it has a right leaf. Okay, 26. Yeah.
Then for 35, we should not place 26 as sir. Root left and right only, no, sir. For 35, it is 26 is right.
For 35, there is only one left leaf, that is 23. What is the problem? Tell me, what is your problem? Can you tell
Okay,
me?
sir. Now I can understand, sir. Okay.
Every time you have to do this root left and right. It's a recursive function. If you have done the coding in that thing in order traversal, you will see that it's a recursive function that is left root right. Here it's root left right. Okay, root left. Okay, there is no right yet. Okay, because we are not yet. Each number you have to take. Okay, you have not reached the right side yet. Okay, now 23. What is a, also you have to remember the rule of binary search trees. The left value should be lesser than the root and the right value should be greater than the root. Okay, since 23 is lesser than the root, it's a left leaf. Now 23 you come down, root left is what? There is no leaf because next is 26. Okay, if there was some 21, then yeah, you could have written 21 here and then here, but that is not possible. Okay, so it's 26 here, which is the right. Now the next number is 46. Now 46, if you go up like this, it's always greater. Yeah. Okay, so yeah, root, one second. One second, I'm just doing this. Yeah. So now 46 will come now as the right root of the 35. Okay. It's the first number, okay, that is greater than 35. Okay. So that will come here as the right root. Insert. Okay. 46. Okay. Did you get that?
Yes, sir.
Sorry. Okay. It's root left, right. Okay. Now 46 is here. Okay. Now 46 will have, if you come down, the first 46, the next thing is 40. Okay. So 40 is the next thing.
It's a left leaf.
So it's the left leaf of 46. Okay. I'll just put, I'll move this here a little bit sideways. 40. Okay. Now the next thing is 39. So 39 cannot be the right leaf of 46, right? Because even 39 is lesser than 46. Okay, so you have to go one level down. Let me introduce some lines here. Okay, and then one more line. Okay. Okay, now next number is 39. So 39 is lesser than 40, right? So then it becomes a left leaf. Insert 39. Okay, and then the right leaf will become 41 because 41 is greater than 40. Okay, so you can do in order and pre-order traversal to any tree. What we have done is for a binary search tree. If you look here examples, okay, left is not strictly less than right. For example, 4 is not less than 2, and but 5 is greater than, both are greater than 2. Okay, so these are different kinds of trees. Okay, they are not strictly binary search tree, whereas this is a binary search tree. Okay, this is exactly like a binary search tree. What we have done is we have applied two things. First, the tree should be a binary search tree such that the left leaf is lesser than the node, right leaf is greater than the node. And the second thing is doing pre-ordered traversal, which is basically root left and then right. Okay, I'll just draw the lines and then it'll become clear. I'll explain this again. I'll explain it in the inverse format. Okay, from the tree I will get your sequence. Okay, let's start. Root left, right. Okay, we have to get back this sequence. Okay, now can you tell me? Uh, yeah. So initially root is 35. Now root left. What is left? 23. Yeah. Now root left, right of 23. There's no left node. There's only right nodes. 26. That is.
Sir, we have one more element in the sequence, 52, last element. It should be placed to the right of 46. Am I right?
You have 50. What?
52, sir, last element of this sequence.
Oh, okay, okay, okay. So this is what 51. Okay.
No, sir, 41. Next to that, it is 52.
Oh, okay. One more element is it? Okay.
Then
No problem.
52 should be placed to the right of the 46.
46.
Am I
Yes.
right?
Yes. 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 Okay.
Okay.
So We'll try and get this back. Okay, so 52 I'll just add here. Hey, no. 52 will be placed not on the right of 46. It will be placed one second. 35. So is the order correct? Is the last element like this only, or 52 was placed anywhere else?
Correct only. So 52 is placed at the last.
At the last only. Okay. Having a little confusion where 52 will be.
52 is greater than 46, then it is the right place.
So if you write this root left right, yeah. But your order will not be. Yeah, correct. Okay. So root left. Okay. So the 46 will come here. Correct. You're right. Sorry. 40 insert 52. Okay, this will come here. And what is this? Insert line. Okay. Yeah. So okay, let's try and reconstruct the tree. Write the sequence again. So root is what, 35, left is what, 23, then again root left right, root left right, 23, there's no left, so 26. Now you have to come to the right side. So root 46, now left 40. Now again for that you have to do root left right, root 39, 41. Okay, 39, 41. Okay, and then you have 52 left, which is basically the right root left, and then now right is 52. Okay, so did you get this, how we got the thing back? Why 52 here? Because 52 is greater than 46. That's the only reason. If you see in a binary search tree, all numbers lesser than 8 are below it, all numbers greater than 10 are on the right side. So the immediately you find a number between that is greater than, say, the root, the upmost root, you have to go to the right of it. For example, here we found initially 46, next after 26 was 46, right? Now 46 you have to go back and see the last number such that 46 is greater than that. It's 35. So it becomes the right of that. And again here down, we got 52 after 41. Now 52, if you go back fully, this is the last number above, which is greater, which is basically the maximum number, which is lesser than 52. Okay, so 46. So it has to go on the right of that. So it becomes a new leaf, 52. Okay, and then you have to follow the root left right principle. Okay, pre-ordered traversal. Is this okay? So the answer I think was 46 in your example. This is the right leaf. Okay. So clear with all this?
Yes.
Okay. Okay, so binary search, remember everything below a given number, say 35 on the left, all the numbers will be lesser than that, and all the numbers on the right will be greater than that. Okay, that is one. Second thing, the left leaf is always greater, smaller than the right. No, it's always smaller than the root, and the right leaf is greater than the root. And pre-order traversal, you have to do root left right. In an in-order traversal, you do left, root, right. Okay, and in-order traversal starts from the bottom, leftmost, bottommost leaf, whereas pre-order traversal starts from the topmost. Okay, from the root. Okay, it starts from the root. Also, I've attached a slide for delete min that we did in the last class. I didn't show you like how I showed you things before, but you can look at this slide to do how to do delete min heap. Okay, it's the opposite of doing delete max heap. Okay, I think we did min heap and not max heap there. Max heap is I think given in your lectures. So look this up for minimum heap. Okay, this is also useful. So all these things are useful. Trees are useful to store data and to search values. For example, binary search tree is useful. For example, if you want to find number, say 14, you don't have to look through the entire thing. You come to the root. Is 8 greater than 14? Yes. So you don't have to search through this at all. You can need to search only through this. You come here. Is 14 greater than 10? Yes. So you go on, you have to go on the, just on the right of this tree again, this root. You don't have to go on the left. You have to go only on the right. And then is 14, you found 14. So it becomes easy. You don't have to go through entire sorts of numbers to find a number in a given data structure. Given that it is arranged in this manner. So binary search trees help you to find elements and do all kinds of things in a more efficient manner. The efficiency is O log n. Okay. Where this is the worst efficiency. If you have to traverse to the entire tree, that is O log n. Okay. Why log n? Because every time you're splitting into two. So log to the base 2 that is. So every time you're splitting into,
Sir,
that's why it's O log n. Yeah, tell me.
sir, you told binary search supports no repetition, right?
Yeah.
If we have same element repeated, should be omitted.
Then yeah, you should not yeah, you should be omitted. Yeah, you can't have more than one value in a binary search tree. Repeating value. See here you don't have anything. This is a binary search tree. These two are not binary search trees. Okay, but this is a binary search tree. So if you see, there are no repeating values. You just can't have a data structure. You can't have a binary search tree if you have repeating values, because then what will your left and right leaf be? If you have, because it has to be strictly greater on the right side and strictly lesser on the left side. You can't have that if you have repeating values. If you had another 8, you can't write 8 here. It's wrong. Okay. Okay. So I
Okay, sir.
think that's it for today, and that will help you solve most of your assignment questions. There was another question based on binary search. I think that was easy. You have to do some four things. Okay. So not much of coding, but more of logic. Coding actually is there. You have to understand the code that is given in the lectures and try it out. The sir has already given you the code. Play around with that code. Okay. Do a left in so there's an in-order traversal. You can do a pre-order traversal. You have to just change the order. You have to do root left right for pre-order and all those things. Okay. Okay, chalo, thank you for today and I'll see you next class, 7 p.m. Hopefully that time my computer will not have problems. See, today my computer is working correctly because I got it fixed in the morning. But hopefully next time these things don't happen. Okay. So see you next time, yeah? Thank you.
Thank you,
And
sir.
thanks for letting me take an extra class. Otherwise I wouldn't have been able to. Okay. Any comments from your side? Yes or no?
No, sir.
Okay. Thank you.
Thank you for
I'll
this
put
class.
everything up. Yeah. In an 2 hours. Give me 2 hours. I'll put everything up. Yeah. Thanks.
Okay, sir.